In this video, we are looking at force diagrams. So we're going to be drawing a diagram that shows the forces acting on an object. The first question says a box of weight W is being pulled to the right by a force P along a rough horizontal table. Draw a force diagram to represent this information. So let's draw our table on here. It's a rough table. Rough tables have friction. So on a rough table, there's a force opposing the motion called friction. On a smooth table, there is no friction. So let's draw our box on. So what are the forces? It's being pulled to the right by a force called P. It's a rough table, so that motion will be opposed by a force called friction. It's got a weight W. Weight is a force that acts downwards. And then to stop the box going through the table, there must be a force equal and opposite. That force is called the normal reaction. So it's a force that keeps it in balance. It's the table pushing back on the box, on the object, so it stays balanced. So this is our force diagram for this situation. There's one for you to try. See if you can give it a go. So I think, is it the same situation? So we've got a box. No, it's a smooth table this time. So on a smooth table, there is no friction force. So there will be no friction force opposing the motion. So it's being pulled to the right by P. Its weight is acting down. The normal reaction is acting up. And that is all the forces for a smooth table. Newton's first law of motion states that an object will remain at rest or with constant velocity in a straight line unless acted on by an external force. So if the forces are in balance, or if there's no forces acting on an object, it's going to stay stationary, it will stay where it is, or it will keep moving at a constant velocity. So it won't accelerate or decelerate. If there is a resultant force, if there is a force overall acting on an object, it will accelerate. Here's another question. Given that the particle is stationary, find the values of P and Q. It could also have said moving at a constant velocity. So either if it's stationary or moving at a constant velocity, the forces must be in balance. So the forces up equal forces down, forces left equal forces right. So Q will have to be 5 newtons and P will have to be 8 newtons. Forces down equal forces up, forces left equal forces right. One for you to try. See if you can give this a go. So again, it's stationary, it's not moving, so the forces must be in balance. Q must be 12 newtons because forces up equal forces down, and P must be 10 newtons because forces left equal forces right. Another one, work out the size and direction of the resultant force. So we can see forces up equal forces down, but forces left don't equal forces right. So the resultant force is 2 newtons to the right. 10 newtons, take away 8 newtons, is 2 newtons to the right. Describe the motion of the particle. It's going to accelerate to the right. And one for you to try. Give it a go. So this time forces left equal forces right, but forces down don't equal forces up. So the overall force, the resultant force, is 20 newtons, take away 15 newtons, which is 5 newtons acting down. So the motion of the particle, it will accelerate down.